This problem focuses on building a deep learning based audio language model that can listen, think, and understand both speech and non speech audio together, just like how humans precise the sound. Currently, most systems work separately. They either recognize speech or detect sound, but not both in an integrated way. This creates a major gap in real world audio intelligence. The challenge proposed by the Ministry of Defense under the Smart Automation theme calls for real-time, secure, and multilingual understanding, especially for Asian language and diverse environment. So, how do we solve this complex challenge? Let's dive in. Here's our solution, SoundSense ALM, India's first AI-powered audio intelligence system. We inject audios from any source like smartphones, camera, or defense feed, then run pre-processing for noise reduction and any voice activity detection. At the core is the ALM engine with two parts, speech for multilingual emotional awareness, transcription, and non-speech for environmental sound analysis. Both feeds a fusion engine that builds full audio sense understanding and pushes actionable insights to the dashboard. Our key innovations are audio sense graph for relationship mapping, cultural context embedding for Asian language understanding, real-time plus offline pre-processing, and cross-module joint reasoning. So let's see how we address the problems. This single platform directly solves the four gaps highlighted here: lack of data sets, missing cultural awareness, fragment audio task, and weak sense reasoning, all unified in one system. Let's start by looking at the technical foundation and the system architecture of SoundSense ALM. For the front end, we are using React plus Next.js, and for the back end, we are using Fast API. And for the database, we are using Superbase with Redis for caching. And for deployment, we are going to use Docker and Netlify. So now let's move to the system architecture. Here's how the system works. Audio flow from the input source, pre-processing module, clean and segment audio, 4 engine processor parallel, speech engine, transcription and language ID, environment engine, sound classification, speaker engine, voice identification and context ether, cultural context analysis. All engines feed into the audio sense graph generator. This graph plus LLM processing engine creates intelligence output. Output are stored in the vector database and shown by the user interface. Now let's move to the web interface and explore the features. This is the SoundSense ALM landing page, clean, functional, and designed for easy navigation. As we scroll down, we can see different sections, a hero demo area, the how it works, workflow, real-time processing capabilities, and feature highlights. Everything here on this page is live, no mockups. Now let's see SoundSense ALM in action. Here's the audio upload interface. I am uploading a Chinese audio file to test the system. Once uploaded, you can see the pre-processing module cleaning the audio and the 4 engines starting their work. The terminal shows real-time background processing, speech engine transcribing the Chinese language, environment engine analyzing the background sound, speaker engine identifying the voices, and context engine capturing the cultural noises. All engines feed into the audio sense graph generator and LLM for intelligence insights. Pre-processing is completed. Here are the results. Transcription of the speech, context-aware English translation, full audio sense analysis, background sound, speaker info, emotions, and situational understanding. Everything here is real-time, fully functional, and shows the true listen, think, understand capability of the system. Now that the analysis is completed, we also have an intelligent chatbot that can answer any questions related to the proceed audio. Here I am testing it live. Let's ask a simple question. What is the summary of the audio? And let's see how it responds to it. The system processes the sense data and provide a meaningful summary based on everything it analyzes. As you can see, it's not just repeating words, it's actually understanding and summarizing the complete audio scenario. This shows how the chatbot goes beyond transcription. It listens, reasons, and responds intelligently in real time.